Hey everyone, I wanted to do a video this week of just showing you how to set up these problems, because if you remember in the last video, the integration actually isn't that tough. You know, once you set the problems up, the formulas are actually pretty easy. What's really hard is knowing when to set them up. So what I want to do is I just got a couple examples here, and I just want to walk you through finding the volume. That's it, okay? All right, so let's look at this first example here. So find the volume of the solid generated by revolving the region defined by y is equal to x cubed, around y is equal to 8, and x is equal to 0 about the y-axis. All right, so suppose you don't even know what y is equal to x cubed looks like. You can load up your graphing calculator here and just plug it in. Like you hit the y equals, I'm going to put in x cubed, I'm going to hit enter, you can just hit the graph, and it looks like this. All right, and so if you look over here, I've just got the first quadrant blown up in here, right? Because I'm going to integrate from x is equal to 0 here to this bounded by y is equal to 8, so this line up here. And like you can put this in here, like if you were to just go down here, y is equal to 8, and graph this, you would see the line y is equal to 8. So it's this like region right here, right? So I want to graph this about the y-axis, so this is a vertical revolution, so this is going to go whoop, like around left to right. All right, so if I'm going to go around the y-axis, it's a dy problem, like you see down here. If I were to go about the x-axis, it would be a dx problem. All right, so my bounds, if it's a dy problem, the volume, I'm going to go 0 to 8, so from 0 all the way up to 8, all right, pi and then r squared. So what I'm going to have to do is I'm going to have to take this y is equal to x cubed, and I'm going to have to solve it for x. So you just get x is equal to, you take the third root of y. So this is your area. It's pi times the radius squared. So you just reintegrate from 0 to 8 pi, the third root of y squared dy. And that's it. And then you could just general power rule this one. All right, so this was just a disk problem, disk method. All right, so let me show you some washer problems, okay? If you remember the washer, all right, our formula here was pi radius squared of the outer radius minus r the inner radius squared. All right, so just remember that both r and y are measured from the axis of revolution. Okay, so I'm going to do some problems where the axis of revolution changes. All right, so it gets a little bit difficult. Like, what if it's not around the x-axis? What if it's around a different line? All right, so here, so find the volume of the solid generated by revolving the region defined by y is equal to 2 minus x squared and y equals 1 about this line, y is equal to 1. All right. So first off here, if you wanted to go in here just to see it, this is 2 minus x squared, and then the other line is y is equal to 1, like this. And you can graph it here, and you can see that it's that little region here. You can even zoom in. It's like if I hit zoom and then number 2 to zoom in and just hit enter again, you can see the region. It's this region right here. All right, so I'm going to do it about the line y is equal to 1. All right, so my bounds of integration, because it's about a horizontal axis of revolution, it's a dx problem. So my bounds of integration, how do I get negative 1 and 1? Well, what I did here is you set this 2 minus x squared equal to 1. That's where it's bounded by, and you solve, and you get negative 1 and 1. All right, so the length here, all right, my radius is what I'm asking for here. Well, notice how I have this minus 1 here. You subtract away, so listen to this is important. You do minus whatever the axis of revolution is. So the axis of revolution is y is equal to 1, so you do minus 1. If you think about it, when the axis of revolution was the x-axis, that's y is equal to 0, so that would be like minus 0, so that's why it's never there. So 2 minus 1 gets you 1. So my radius here is actually just 1 minus x squared. So to find the volume of this little thing, if it goes whoop, around like this, you'd integrate from negative 1 to 1 pi, not 2 minus x squared, but it became 1 minus x squared squared, and then obviously dx, right? So that one wasn't too bad. All right, so we determine a cut that a cut perpendicular to the axis of revolution will either form a disk, right? This is a region that touches the axis of revolution, or something that does the like the x-axis, like here it was y is equal to 1, so it actually touched the axis of revolution. So a washer is when there's a gap, all right? So revolving around the line y is equal to 1 here, because it touched it, actually formed a disk. However, when you revolve around the x-axis here, there's going to be a gap, and that's going to need the washer method. All right, so let's do this problem again, revolving around the x-axis. So find the volume of that same problem, all right, the solid generated by revolving a region, that same region, about the x-axis, all right? So we saw from the last video here, my bounds are not going to change. My outer radius here is the equation for the function, which is just 2 minus x squared. My inner radius here is just y is equal to 1. All right, so there's this is an incredibly easy inner radius, y is equal to 1. All right, so when I integrate this, that area is pi times the outer radius, 2 minus x squared square, minus pi times the inner radius squared. So setting this volume up, it would just be negative 1 to 1 pi times the outer radius squared minus pi times the inner radius squared. And you can even factor out the pi if you remember from my other videos. All right, but let's change the axis of revolution. All right, say the axis of revolution was not the x-axis, or y is equal to 0, but let's change it, all right, and revolve it around the line y is equal to negative 1. All right, so notice how in the previous example it was the x-axis, but here the axis of revolution is y is equal to 1. So you're revolving it further around. All right, so the bounds of integration don't change. But notice how, like, when I went back here, all right, here, when I did a different axis of revolution, I minused whatever the axis of revolution was. All right, like here it was the line y is equal to 1, so it was radius minus the axis of revolution. So here you do the same thing. You do the outer radius, which is 2 minus x squared, minus the new axis of revolution, which is minus 1. So minus minus 1 actually becomes plus 1. So 2 plus 1 gets you 3. Now the inner radius, all right, remember, was y is equal to 1 minus the new axis of revolution, so minus minus 1. So it becomes 1 plus 1, or 2. All right, so that's the area of that solid right there in the plane region. So to find the volume, you would integrate from the bounds, negative 1 to 1, outer radius squared minus inner radius squared, both times pi. And these two integrals would actually be incredibly easy to do, or excuse me, this single integral. All right, let's do a like a harder problem here. All right. So let R be the region in the xy plane bounded by, this is weird, y is equal to 4 divided by x squared, and the line y is equal to 1/4, and x is equal to 2. So set up the integral for the volume by rotating R about the x-axis. So again, if you have no idea what this looks like, you can just plug this in. Oop. Let me just restart my calculator here. So let me clear both these things out. So I'm doing y is equal to 4 divided by x, and then 1/4, which is just 0.25. If I zoom standard this is the line y is equal to 4 over x. Let me just zoom in so you can get a better idea. So zoom in too. This is the line, and here's y is equal to 1/4. Let me zoom out. Sometimes you have to play with this a little to get a good idea. But you can see that the top radius here, all right, is going to be 4 over x. The bottom radius is going to be 1/4. Our one bound of integration is going to be x is equal to 2, but then we need the other one here. So actually, if you look here how I set this problem up, right, here is y is equal to 4 over x. This red line here is y is equal to 1/4. The bottom one was 2. If you set these two equal to each other to find the other bound of integration, you would get 16. All right, so the outer radius is 4 over x. The inner radius is 1/4. And then since we're going over the x-axis, This would be the outer minus the inner squared, and the volume would just be integrating from 2 to 16 pi outer radius squared minus pi inner radius squared dx. So this actually integrating this is not hard at all, right? But setting it up can be rather difficult. Right? You would just general power rule this one, and that's just the integral of a constant. All right, this one right here. So let R be the region bounded by this. Right? So set up the integral for the volume of the solid revolving by rotating the region about the x-axis. All right. So use perpendicular. So when you do perpendicular slices, that's dx problem. All right, but suppose you have no idea like which one's on top, which one's on bottom, which is the outer, which is the inner radius. So you can just use your calculator here to help you. So 2x squared is one of them, and then 3x minus 1 the other one. I'm going to zoom standard this. So it's tough to see this one here. So if you're like, I don't know which one is which, let me zoom in. Sometimes it's tough and you have to play with it to figure it out. Like if you want to zoom again, you can get zoom and then 2 to zoom in, and you can like move over where you want to zoom into. So I'm going to like move in over to like looking where they try to cross. And you can just see here that the linear line, just by looking at it, is going to be on top of the parabola here, the quadratic. So this, going back, this guy is my outer radius, and this is my inner radius. So when you set this up, the outer radius is this, the inner radius is the quadratic. You can see it right here. All right, so to figure out the bounds of integration, you actually just set these two equal to each other and solve. And these two will be equal to each other at 1/2 and 1. That's where they cross. So you're going to integrate from 1/2 to 1. Outer radius squared minus the inner radius squared. And then you just do this integral, and it's pretty much a piece of cake. All right? Let me just do one more, just another easy one for you guys. All right, just so you can see it. So find the volume of the solid generated by revolving the region y is the square root of x. X is equal to 3. And the x-axis about the x-axis. So my bounds of integration are going to be from 0 to 3. This is the radius. The radius squared is just x. So when you square the square root of x, you just get x. Literally doesn't get any easier than this one. This was just a disk problem. All right, so I've done a bunch of examples here of setting it up for you. To help you, use your graphing calculator here. That's incredibly useful to seeing it. And zoom in, zoom out to figure out which is the top and bottom one, especially when you're using your WebAssign. All right, do this one. All right, everybody. Good luck on your work this week, and please stay on top of your WebAssign.